Have you ever imagined that we might be able to, like, listen to black holes?
Yeah.
Whispers of black holes.
Yeah. It sounds like...
Sounds like sci-fi, right? But that's exactly what we're diving into today.
Yeah.
You're interested in the latest black hole research, and this new discovery is definitely turning heads.
That's right.
Yeah.
The whispers we're talking about aren't sound waves, like how we typically think of them.
Right.
It's light echoes, and it's a groundbreaking way to observe these cosmic giants.
Light echoes from black holes.
Yes.
Okay, that's definitely piqued my curiosity.
Good.
I understand that our main source for this deep dive is an article from the Astrophysical journal Letters, and it sounds like it has some pretty big implications.
It does.
Can you give us a taste of what's got everyone so excited?
Absolutely. We're talking about potentially revolutionizing how we measure a black hole's mass and spin.
Okay.
And we're not talking about relying on the accretion disk, which can be a bit of a distraction.
Right.
This new method is completely independent of that. It's like finding a new, clearer window into the heart of these mysterious objects.
That's a game changer.
Yeah.
But before we get ahead of ourselves, can you walk us through the basics?
Sure.
What exactly are light echoes and how do they even work?
Okay, so it all starts with the incredible way black holes warp the fabric of space-time itself.
Okay.
Picture a bowling ball on a trampoline,
Okay.
causing a dip in the surface.
Yeah.
Now, imagine that bowling ball is a black hole, and the trampoline is space-time.
Okay.
The intense gravity of the black hole bends the path of light rays that pass nearby, almost like a lens.
Okay, I can picture that.
Good.
So how does this bending of light create these echoes?
So think of it like this. Some light rays from a source behind the black hole will travel directly to us.
Okay.
Other light rays, however, will be bent around the black hole due to its gravity.
Right.
These bent rays take a longer, curved path to reach us, and that's what creates the echo.
So we're seeing two versions of the same light. One that traveled straight to us, and one that took a detour around the black hole.
Right. That's incredible.
Exactly.
Yeah.
And because we know the speed of light, we can calculate the difference in arrival time between these two light signals.
Okay.
This delay, this echo, is what allows us to probe the black hole itself.
Wow.
It's a powerful tool for understanding its properties.
That makes sense.
Good.
It's like hearing an echo in a canyon.
Yeah.
The sound that reaches your ear directly arrives first, followed by the sound that bounced off the canyon walls.
Exactly.
Except in this case, we're dealing with light, not sound, and a black hole instead of canyon walls.
That's a good analogy.
Yeah.
But what's really exciting is that these light echoes can give us much more precise measurements of a black hole's mass and spin.
Why is that so important?
Yep.
And how is it any different from the methods we've been using up until now?
So traditionally, we've relied on observing the accretion disk to estimate these properties.
However, the disk's own light and motion can interfere with our measurements, making them less accurate.
Okay.
Light echoes, on the other hand, allow us to bypass the accretion disk entirely and study the black hole's gravitational influence directly.
Interesting.
It's a much cleaner signal.
So we're getting a clearer, more accurate picture of what's happening around the black hole itself.
Exactly.
It sounds like a huge leap forward for black hole research.
It is.
But how did the researchers actually manage to discover these light echoes?
Yeah.
Were they just looking up at the sky and hoping to spot them?
It was much more complex than that.
Okay.
They used incredibly detailed supercomputer simulations to create a virtual black hole.
Wow.
Specifically, they modeled M87, the supermassive black hole in the galaxy M87.
So they created their own mini-universe in a computer.
Yes.
That sounds incredibly ambitious.
Yeah.
But how does that help them study light echoes?
By creating this virtual black hole, they could precisely control and manipulate the conditions around it. They modeled the extreme gravitational field and then traced how light rays would travel through this warped space-time.
Interesting.
It's like setting up a controlled experiment on a cosmic scale.
I see. So they could watch how the light got bent and twisted, creating those echo paths.
Exactly.
Fascinating.
Yeah.
But how did they find these echoes within all that simulated data?
Wow.
Weren't they incredibly faint and difficult to spot?
You're right, they were.
Yeah.
It's like trying to hear a whisper in a roaring stadium.
Right.
The researchers had to develop sophisticated algorithms to isolate these faint echo signals from the overwhelming glare of the black hole's direct light.
Wow, that must have been a huge computational challenge.
Yeah, it was.
But they actually managed to do it.
Yes.
They successfully identified the echoes, right?
They did.
Wow.
And what's even more remarkable is that they took tens of thousands of snapshots of the light as it traveled around the black hole.
Okay.
It's like creating a high-speed film of light's dance with gravity.
That's incredible. It really paints a picture of the complexity and precision involved in this research.
Absolutely.
So we've talked about what light echoes are and how researchers discovered them.
Right.
But what does this all mean for the future of black hole research?
Well,
Why should we be excited about this?
the implications are vast.
Okay.
For one, it allows us to test Einstein's theory of general relativity with even greater precision.
Because if these echoes don't behave exactly as predicted by general relativity, that could point to some new, undiscovered physics.
Yeah, exactly.
Yeah.
It could potentially rewrite our understanding of gravity, the fundamental force that governs the cosmos.
Wow.
And that's just scratching the surface.
Okay.
We're going to delve into these implications and more
Is there
after a
some-
quick break.
Okay. I'll be right back.
We'll be right back. Stay tuned.
Stay with us.
Welcome back.
So before we went to break, we were talking about how the discovery of light echoes could potentially challenge Einstein's theory of general relativity. It's a pretty big deal. If these echoes don't align with what Einstein predicted,
Yes.
it would really shake things up in the world of physics.
Uh-huh.
Could you elaborate on that a bit?
Sure.
How exactly could these echoes contradict general relativity?
Einstein's theory describes gravity as a curvature of space-time caused by mass and energy.
Okay.
It predicts how objects, including light, should move in the presence of strong gravitational fields, like those around black holes.
So if the light echoes behave differently than what general relativity predicts,
Yeah,
it would suggest that our understanding of gravity might be incomplete.
precisely.
Okay.
For instance, if the light echoes arrive sooner or later than predicted,
Right.
or if they exhibit unexpected patterns, it could indicate that gravity behaves differently around a black hole than we currently understand.
That's fascinating.
Yeah.
It's almost as if these light echoes are giving us a new way to test the limits of our knowledge about the universe.
Exactly.
Yeah.
And that's what makes this discovery so exciting.
Yeah.
It opens up a whole new avenue for exploring the fundamental laws of physics.
You mentioned earlier that these echoes could also help us refine our understanding of black holes themselves.
Yes.
How so?
Well, as we discussed, light echoes provide a more precise way to measure a black hole's mass and spin.
Right.
And these properties are crucial for understanding how black holes grow,
Okay.
interact with their surroundings,
Yeah.
and influence the evolution of galaxies.
Could you give us an example of how a black hole's mass and spin affect its surroundings?
Sure, a black hole's spin can influence the formation and behavior of jets,
Okay.
those powerful streams of particles and radiation that shoot out from the poles of some black holes.
Gotcha.
These jets can have a significant impact on the surrounding gas and dust,
Mhm.
even shaping the evolution of entire galaxies.
Wow. So it's not just about the black hole itself.
Right.
It's about understanding its role in the larger cosmic ecosystem.
Absolutely. Black holes are not isolated objects. They are integral parts of the galaxies they inhabit, and their properties have a ripple effect on the universe around them.
Now, remember you mentioned something about using a space-based telescope in tandem with Earth-based telescopes to study these echoes.
Yes.
Could you explain a bit more about how that would work and why it's so beneficial?
Certainly imagine two telescopes, one on Earth and one in space, observing the same black hole.
Okay.
By combining their signals, we can create an image with the resolution of a single telescope as large as the distance between them.
So we're essentially creating a virtual telescope that's millions of miles wide.
Exactly.
Ah.
This technique is called interferometry,
Okay.
and it allows us to see much finer details than we could with either telescope alone.
That makes sense. It's like having a much more powerful zoom lens on the universe.
Precisely. And when it comes to studying faint signals like light echoes,
Yeah.
this increased resolution is crucial.
Hmm.
It would allow us to observe the echoes with incredible clarity, revealing subtle features and variations that might otherwise be missed.
So by using both space-based and Earth-based telescopes,
Right.
we can essentially boost the signal and get a much clearer picture of what's happening around the black hole.
Exactly.
That's amazing.
And not only that,
Yeah.
but it would also allow us to observe these echoes over a longer period of time.
Okay.
Having a telescope in space provides continuous observation, unhindered by the Earth's rotation or atmospheric interference.
So this combined approach could potentially unlock a treasure trove of information about black holes and their echoes.
Absolutely. It's a glimpse into the future of black hole research, a future where we can probe these enigmatic objects with unprecedented precision and detail.
It's pretty mind-blowing.
Yeah.
It's incredible to think that we're just beginning to scratch the surface of what we can learn about black holes.
Right.
But before we get lost in the cosmos, let's bring it back down to Earth for a moment.
Sure.
Why should all of this matter to someone who isn't an astrophysicist? What's the relevance of these discoveries to our everyday lives?
That's a great question. It's easy to feel disconnected from these seemingly distant and abstract discoveries.
Yeah.
But understanding black holes isn't just about satisfying scientific curiosity.
Okay.
It's about understanding our place in the universe and the fundamental laws that govern reality.
I could see that it's like trying to understand the intricate workings of a watch.
Yeah.
Even though we might not need to know the details of every gear and spring to tell time,
Right.
appreciating the complexity and precision of its mechanism deepens our understanding of the watch as a whole.
Exactly. And the universe is like a cosmic watch, with black holes playing a crucial role in its intricate machinery. By studying black holes, we're not just learning about these fascinating objects.
Right.
We're also gaining a deeper understanding of the fundamental forces that shape the cosmos,
Yeah.
the processes that gave birth to stars and galaxies,
Yeah.
and ultimately the conditions that allowed life to emerge.
That's a beautiful way to put it. It highlights the interconnectedness of everything in the universe.
Yeah.
Even the most extreme and seemingly distant phenomena, like black holes, have a profound impact on our existence.
Precisely. And these light echoes are offering us a unique opportunity to eavesdrop on the conversations happening in the heart of these cosmic giants. Conversations that can reveal secrets about the universe's past, present, and future.
And those secrets could potentially rewrite our understanding of physics, gravity, and perhaps even the very fabric of reality.
Without a doubt. And that's the power of scientific exploration.
Yeah.
It's about pushing the boundaries of our knowledge, challenging our assumptions, and constantly seeking deeper truths about the universe we inhabit.
Well said. So to our listeners who have joined us for this deep dive into the fascinating world of black hole echoes,
Yes.
I want to thank you for your curiosity and your willingness to explore these mind-boggling concepts with us.
And if this conversation has sparked your interest,
Yeah.
I encourage you to check out the full article in the Astrophysical Journal Letters.
It goes into even more detail about this groundbreaking research.
It does.
And as you ponder the implications of these light echoes,
Yeah.
I'd like to leave you with this thought.
Okay.
If black holes, once thought to be silent and invisible, can now talk to us with light,
Right.
what other seemingly impossible conversations might the universe be waiting to have?
That's a great question.
Keep exploring, keep asking questions.
Yes.
And who knows what amazing discoveries await us in the vast expanse of the cosmos.
Exactly.
We're back and ready to continue our deep dive into the world of black hole echoes.
Yes.
Before we were talking about the profound implications these echoes have, not just for astrophysics,
Right.
but for our understanding of the universe as a whole.
Right.
It's pretty amazing to think that something as seemingly distant and abstract as a black hole
Yeah.
can actually tell us so much about ourselves and our place in the cosmos.
That's the beauty of scientific exploration.
Yeah.
It often reveals these unexpected connections.
Right.
Showing us that even the most extreme phenomena in the universe are intertwined with our own existence.
Absolutely. And speaking of those connections, you mentioned earlier that the researchers used a very specific black hole for their simulations.
Yeah.
M87.
Uh-huh.
Is there a reason they chose this particular black hole?
You're very observant.
Oh.
Yes, there's a good reason for that. M87 is a supermassive black hole,
Okay.
millions of times more massive than our sun.
Wow.
It's also relatively close to us, cosmically speaking.
Right.
And it has a very active accretion disk, which makes it a prime target for observation.
So it's kind of like the perfect laboratory for studying these light echoes.
Exactly. And remember those incredible images of M87's black hole shadow captured by the Event Horizon Telescope a few years ago?
Oh, yeah?
Those images gave us our first direct glimpse of a black hole.
Right.
And they were a major breakthrough in black hole research.
Right. Those images were all over the news.
Yeah.
They were truly awe-inspiring.
They were, and now with the discovery of light echoes, we have another powerful tool for studying M87 and other black holes like it.
Okay.
We can combine these different methods to create a more complete and nuanced picture of these enigmatic objects.
It's almost like we're slowly piecing together a cosmic puzzle.
Yeah.
With each new discovery adding another piece.
Exactly.
But I'm curious, if these light echoes are so faint and difficult to detect,
Uh-huh.
how can we be sure that what the researchers observed in their simulations is actually real?
Hmm.
How do we know it's not just some artifact of the simulation itself?
That's a very important question, and it's something that scientists always consider when interpreting the results of simulations.
Right.
In this case, the researchers took great care to validate their findings.
Okay.
They compared their simulation results to actual observations of M87,
Interesting.
looking for any inconsistencies or anomalies.
So they basically cross-checked their virtual black hole with the real deal.
Exactly, and the results were remarkably consistent, which gives us confidence that what they observed in the simulation is a genuine phenomenon.
That's reassuring. It's amazing how much we can learn about the universe through these sophisticated simulations.
Yeah.
But I want to go back to the idea of using a space-based telescope in tandem with Earth-based telescopes to study these light echoes.
Okay.
You mentioned it before, and it sounds like it could be a real game changer.
It absolutely could. Right now, we're limited by the size and location of our telescopes here on Earth.
Right.
But imagine having a telescope in space millions of miles away, working in sync with our ground-based observatories.
It would be like having a giant eye in the sky, peering into the depths of the universe with incredible clarity.
Exactly. And the ability to combine these signals would give us a level of resolution that's simply not possible with current technology.
Wow.
We could potentially see the details of these light echoes with unprecedented precision,
Yep.
revealing new insights into the behavior of black holes and the nature of gravity itself.
That's incredible. It makes you wonder what other secrets the universe is holding, just waiting for us to develop the tools to uncover them.
I agree. Every new discovery opens up a new window into the cosmos. And it's both humbling and exhilarating to think about all that we have yet to learn.
Well said. So to our listeners who have joined us for this deep dive into the fascinating world of black hole echoes, I want to thank you for your curiosity and your willingness to explore these mind-boggling concepts with us.
And if this conversation has sparked your interest,
Yeah.
I encourage you to check out the full article in the Astrophysical Journal Letters.
It goes into even more detail about this groundbreaking research.
Absolutely.
And as you ponder the implications of these light echoes, I'd like to leave you with this thought.
Okay.
If black holes, once thought to be silent and invisible, can now talk to us with light,
Yeah.
what other seemingly impossible conversations might the universe be waiting to have?
That's a great question.
Keep exploring, keep asking questions, and who knows what amazing discoveries await us in the vast expanse of the cosmos.
Exactly.